guys, and Steve, you'd asked me about this particular question, 54 here, so I'm going to try and illustrate this rather than try and describe it in a text. I'm going to try and show you the process here. So, the diagram shows part of a circuit, an insulator gate field effect transistor. There's a voltage divider here, a potential divider as we can see on the input. And it mentions here we're using a moving coil meter. It has a full scale deflection of 100 microamps and a 100 kilo ohm multiplier resistor to give a meter of 0 to 10 volts. Okay. The meter reading will be approximately what? Now, I don't know how you've gone about it so far, but in terms of the working, obviously just here we have this voltage divider, and so the point that we need to calculate is, whoops, bear with me, it's just come on. So the bit we need to calculate is in the middle, just here, the voltage at this point. Okay, so how do we do that? Well, normally with a voltage divider we use the good old equation of V for the supply equals, why won't this stay, keep going, V times, oh my gosh, right, okay, let's just write it down here. So we've got V, that's the supply voltage, times R2, which is 120 kilo ohm, and all that is divided by R1 plus R2. Now, I'm just looking at this here, and we need to bear in mind this is a moving coil meter, so the resistance of the meter, if it's similar in size to these voltage divider resistors, will have a massive influence on them. So if we're connecting a meter, and the meter is connected, hold on, the meter is connected across here, like so, that is effectively in parallel with this 120 kilo ohm resistor. The meter is actually 100 kilo ohms, so it's almost exactly the same. So the combined resistance of those two is effectively going to be about half of what the 120 would be by itself. So we need to work out what the parallel circuit is here in terms of resistance, and then we can work out what the resistance is through the potential divider. So in order to do that, we need to use the equation that is, bear with me, the equation, let me just try and type in here, so it's going to be 1 over the total resistance equals 1 over R1 plus 1 over R2, etc. So R1 is 120 kilo ohm, R2 is the 100 kilo ohms, and if we calculate that out, we should get, so let's work this out, 1 over R1 is 120,000 plus, open brackets, 1 over R2, which is 100,000. Okay, so we've got that number, and then 1 over that is going to be the answer, which is 54545 dot 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 dot. So this is 54,500 ohms. We can now use this equation below here, but we need to change the 120 to this 54. So let's do that. Let's go total voltage multiplied by that funny number divided by R1, which is 220,000, plus the 5454545455455. Right, and there's the answer. So near enough 2. So in terms of the question, the answer to the question is going to be the B, 2 volts, which I think you mentioned in the question that you sent me was the answer. So this is the working. I hope you followed that fine. Please let me know if you have any questions, and please let me know once you've got this if it all makes sense. Thanks very much.